Hello. Today we're going to be talking about uh, uh, text data in the context of natural language processing and learning from sequences. This is a continuation of the lecture last week on Wednesday, so I refer you to that video recording. For the background discussion on this. Some quick review. We want to uh, treat text as a sequence of words, and we will have a fixed vocabulary of words, and we're going to represent each word as a ordinal number. And the word ordinal number really refers to the index. So this really is just a fancy way of saying index of a array. And since the vocabulary is a set, so this is really a set of words. Since the vocabulary is a set, when we store it as an array, the sequence is quite arbitrary. So ordinal number of words are just integer labels. So they bear no information with respect to the magnitude. And anyways, the problem we have at hand really is that we need to perform classification on text. So we want to build a classification classifiers on text data. And the function we're trying to learn is really one that maps integer sequences to some vector space. So what I want to work with today is the IMDb movie review dataset, where we'll look at how we can load the data. We're going to also work with encoding of words to ordinal numbers. And there are some complications that we need to pay attention to with respect to this encoding. Finally, we're going to look at the embedding layer in this video. And so this will provide enough information for us to explore the recurrent neural networks on Wednesday's lecture. Okay, so let's get started then. The Keras notebook will be under Shared Lecture Notes 2021-0321 Sequence Learning. So I'm going to start my Python Jupyter Notebook, and I'm going to call this, we'll call this text learning. Okay. So first, let's import the various TensorFlow packages. I'm going to import Keras. I'm going to import TensorFlow.keras.datasets, and I will also import something like the layers, and let's just import NumPy SNP. It's possible that we might need other packages. If I do, then we'll just come revisit this cell and add the missing packages if necessary. Okay, so first let's load the IMDb movie review dataset. And Keras comes with a movie review dataset, which is given by the datasets.imdb.loaddata API. And there are a couple of parameters that we can tune. As the first attempt to familiarize ourselves with the dataset, we'll just use the default values for everything. So let's just do datasets.imdb.loaddata. And okay, so there, it'll take a while to load the data. Okay, here we go. You can ignore the warnings. Basically, what happens is that these this data set contains sequences of text, and of course, not every movie review has the same length, and by default, Keras or TensorFlow tries to convert this into ND array, but since every row in the ND array has a different length, we get a ragged nested sequence. So that's where the warning is. Okay, the data set is similar to the MNIST data set. It's split between training and testing data. So we're going to just like the MNIST, we're going to split this to training portion and the test portion. This is done for us, so we don't really have to do any data processing, which is quite great. And let's just take a look at the first training. And you can see that it's already encoded as ordinal numbers. So the movie review obviously has words, I suppose. In fact, the first one reads like, this film was just, etc. And each of these is mapped to some unique label. And that unique label is translated to the first one, you will see that that's actually just a special token, and then 14 22 16 43. So this is 14 22 16 43, and the next word happens to be 530, and so on. Okay, and there's a special token of 1. We'll see what that is. Okay, so that's this is the training data, or the input data, I should say. And the movie review maps this to 0 and 1. Okay, and it turns out that the first one, as we will see soon, is a positive movie review. So this should give us a positive sentiment, and 0 is a negative sentiment. This movie review should be mapped to 1. Okay, so let's see. The Y train, and you can see yes. So the first movie review is a positive one. I believe the second movie review is a negative one. Okay. Now, how do we actually read the movie review? For that, what we need is we need to load the so we need to load the word index lookup table. So index is going to be the datasets.imdb, and there's an API that does it for us. Okay, and there it is. Now, you might be tempted to just have these ordinal numbers be used in the lookup table. So the index, this word index, is a dictionary that has the word as the key, and then the integer ordinal number as the value. Okay, and it would be tempting to, if we want to know what 14, 22, and 16 are, it would be tempting to reverse these to produce a lookup table where we have the ordinal as the key, and the word as the value, and then we can just decode it like such. Well, if you do this, you would actually get garbage. Okay, so, and that's why I'm preparing this video to clear out some of the frequently committed mistakes in working with NLP text encoding. As it happens, that the vocabulary is always incomplete. So you always encounter words that one has never seen in the vocabulary before. So it's never complete with respect to the open world that the network will be used. And therefore, there's going to be a very special token called unknown. It's also known as OOV, which stands for out of vocabulary word. Okay, so OOV, aka unknown, is a special word which will stand for anything we've ever seen before. So there's a special token in the vocabulary that we want to include to account for the incompleteness of the vocabulary. And there are other things, such as this one. That stands for the start of a sentence. So we don't generally mark the end of a sentence, but we mark the start of a sentence. Finally, there's going to be another sequence which we use to keep all the sequences in a training data of the same length. So we'll talk more about this on Wednesday. But there is going to be another token which will be encoded to a special value called pad. Okay, so there's going to be this padding. There's going to be this start. There's the out of vocabulary. And so all these things are special tokens that are not typical words in the natural language sentences. And they will be given encodings of 0, 1, and in the case of the OOV, or I should say unknown, a 2. And the default behavior, so as you see in the documentation, so OOV is set to be 2, the start is set to be 1. And it turns out that anything less or equal to 3 are reserved for these special kind of weird symbols. So there's going to be another empty slot which is currently unused, and that's going to be 3. Okay, so all of these are special symbols that this encoding assumes, and therefore your words only start at index value 4. So this might be world, computer, who knows, right? Just some arbitrary list of words, hundreds of thousands of them included. And this is your true vocabulary. And this is more like just the application specific tokens. Okay. Now, what the difficulty is that the word index for the true vocabulary starts at 0, not 4. Actually, it starts at 1. Sorry, it starts at 1. Nobody ever uses 0. So it starts at 1, not 4. And if you do the lookup, this ordinal is what gets used in the application. So this is used by your neural network application, which 0 to 3 are special, and then 4 to everything else is your true value. But the word index, the true value starts at 1 to infinity. So what we have to do is we have to build up this index from the word index by adding 3 to each of the ordinals. Okay, so I think that's easier to explain as code. So what we're going to do is we're going to build the lookup table. So this is the word index table. and then we're going to build the lookup table. So I'm going to call it ID to word, and this is going to be the index to so this is a dictionary of index plus 3 and the word for every word and index in index dot items. Okay, and the first few we can 0 means pad, 1 means start, 2 is unknown. Oh, I should and so currently 3 is unused. So we shouldn't see really the occurrence of ordinal encoding of 3. Okay, so now this ID to word, the keys are the encodings used by the application, which is the training, and the values are the actual English words. So now we can make use of this ID to word and decode exactly what the X-train the first training sequence is. So what I'll do is I'll just do a split and have this also as code. So here is X-train of 0. It's got how many? So it's got 200 words, which is quite a bit. So what we're going to do is we're going to run it as a convert this to a NumPy array so that it has a nice display for it. But even that is okay. Maybe what we'll do is we'll just show the first few. So I'm just going to show maybe the first 10. Okay, so here they are, and we want to know what it means. So now here I can say let the it's going to be the ID to word of W for or I guess of I for I in X train of 0. So there it is, and this makes sense, right? And you really want to do this as you are doing your own text training, because you want to see if the sequence you're working with is actually a sensible piece of text. So here, let me just convert this to a string. So here it is. It says, this film was just brilliant casting, location, scenery, story, direction. Everyone's really suited for the part they played, and you could just imagine being there. So this is definitely a positive review, and it is indeed so. So let me just take the first 10. So there it is, right? So that these 10 tokens correspond to these English words, with the first one being the start. Okay, so what I'm going to do is I'm going to just define a function, and I'll call this decode, and we're given the ordinals, and here I'm going to return join id to word dot get id, and if I don't, if the id is not part of this, then it really should be unknown, but it should really have been there for I in the ordinals. Okay, so I can use this then to say, well, let's decode x train of 1. And here it is. This is a bad review. If you recall, like, let me just include the output. So you can see this is the output is a 0, which means it's a negative sentiment, and it reads big hair. Anyways, I'm not going to read it, but you can read it yourself. It's a bad review, and it's labeled as bad. Okay. All right. So what we're going to do is we are going to explore some of the parameters that are here. Now, when we look at, for instance, take a look at the first one, or maybe just the random one. You're going to see words that are actually very, very infrequent, and words that are so rare that it doesn't really become useful. So, for example, if you look at that's a very so I'm trying to see this piece of text. They had earned working to watch this feeble excuse. So this is a negative review. But to think that this word 1990s is here, this word may or may not be relevant to the review of being positive or negative, right? And in order to reduce the vocabulary so that we have an easier time to do the training, very often what happens is that we want to keep only frequently occurred words in the entire corpus. And so the number of words are the words that are this frequent to be kept. So any less frequent words will be treated as out of vocabulary. And by default, since we did not specify a value for the number of words, what we just saw is that all the words are kept. And this led to a very large vocabulary. So in fact, we can take a look at how big the vocabulary is. So here's the, well, actually, maybe I'll just add it here. The vocabulary size is, and it's really just the length of the word index. Okay, so it's got 88,000, which is not too bad actually, but nonetheless, we can reduce this. All right, so the next thing, what I'm going to do is I'm going to reduce this to a much smaller vocabulary size. Now, by specifying the number of words, the skip top is another parameter that we can use, and skip top skips the top n most frequently occurred words, which may not be informative. So if you look at this, things like the, all right, are definitely highly frequently occurring. And I wouldn't think that it's very useful, or a. or right? Or even is. They're so frequently occurring that we do not believe that they contribute significantly to the determination of whether this is a positive or negative review. And we might want to remove these as well to make the training easier. And so let's just reload the data set. So let's a reduced data set can be and loaded by specifying these parameters. So I'm going to say number of words, and I'm only going to take the 10,000 or even 1,000 most occurred words. So anything that's more rare than the top 1,000 frequent words, we would just throw away. And we're going to skip the top 5 words, and that's it. Okay, so and then we'll have X train, Y train, and X test and Y test equals to data. Okay, so this will load the reduced data set, and let's try to decode X train of 0 again. And we can see that it's quite different than what was there before. So before it read, this film was just brilliant casting, location, scenery, story. And the new one says, this film was just brilliant casting, and then we don't know, and then story, direction, we don't know, really. So some of these unknowns are actually just introduced because we are limiting the words to be just the top 1,000. So because these are outside of the top 1,000, or that they are the top 5. So all of these are now out of vocabulary. So the vocabulary is very much reduced, and therefore these things are very much reduced as well. Okay. So that's one thing. Now the next movie review is also, well, so a lot of these like, words that were there before are now filtered out just because they are so rarely occurring among movie reviews. Okay. Well, so this is how we can work with the data set, and we can also use the reverse of ID to word to perform encoding. So what we can do is we can let's do the so to encode text to ordinals at the application level, we compute the reverse lookup table. Okay, so we're going to call this word to ID, and this is basically just the word of ID for ID to word in ID to word dot items. There it is. Okay, and then we can do a encode where we're given the text, And so all we need is we need to return the word to ID of the word that we encounter, but the word might not be part of the word to ID. And so if it isn't, then we have to return the out of vocabulary. So, and that would be like the value 2 for word in text dot split. So we're just going to split by white space in this case. So now I can encode, for instance, I'm just going to paste a piece of text, and that gives us the that sequence. Okay. All right. So that's good. Now, so this gives us the ability to convert any text to a sequence of ordinal numbers. And on Wednesday, we're going to come back and we're going to continue with the discussion as to how we will use embedding layers followed by recurrent neural networks to build a network architecture that allows us to take text encoding as ordinals to a vector space, to some forward layer, and finally to the sentiment of 0 and 1. And we will use the training data to train this, and we'll see how we're going to train a network that's able to basically achieve accuracy around like 80% or so. So we should be able to achieve this somehow using the just very basic elements of embedding layers and followed by RNN. So all that will be done on Wednesday. And for this video, just make sure you feel comfortable with working with the Keras IMDb data set. And let's not take for granted all the hard work that the IMDb dataset API is doing for us, in that it is doing a lot of the pre-data processing that one need to do, such as building up the vocabulary, performing the text encoding, and gathering the data in a reduced form when necessary. So when you're working with your own data set, you might have to do some of the text pre-processing yourself. And Keras has some utility that helps you to do that with the Keras pre-processing APIs. And so the Keras pre-processing API helps you to do some of these things. So there's tokenization and preparing the text data set from some directory structure that might make it easier for you to get this type of clean data from some messy data. Okay, unfortunately that's beyond the scope of this course, but it really isn't too difficult. Just take a look at this and you'll see how you can use a tokenizer among other things to help you with that. All right, this will be made available online, and you can play with it with this video as well. I'll see you on Wednesday.